Hello, hope you're doing good and welcome back to my channel. Today we are at day 5 of the Make Daily Leetcode challenge and we have a medium level question for the vowels. Let us see what the question is. It's question 1456. Maximum number of vowels in a substring of given length. Okay. Let me give you a gist of what the question is. We, see, this is a string given to us and integer is given to us. This is called k. Okay. Let us see the question. Given a string as an integer k, return maximum number of vowel letters in any substring of s which that means we have to consider all possible substrings of length k, and in them among them which we have to count the number of vowels in each of them, and we have to return the maximum number of vowels. Okay, I will again repeat. See, we have to consider all possible substrings of length k. Okay, all possible substrings of length k. In all of those possible substrings we have to count the number of vowels, and finally we have to return the maximum number of vowels present in each of those substrings which are of length k. Okay, and for vowel letters they are considering these things which we already know: a, e, I, o, u, right? So let us quickly go through some of the examples. See, first we will consider ABC. Okay, ABC is a substring of length 3 because k given is 3. Okay, so let me zoom it properly here. So ABC first. Okay, you can clearly say A is a vowel, so count is 1. Okay, please keep noting down. I will like trace you in the program also. I will show trace and show in the program also. But first of all, let us manually understand what it is. Okay, so please follow with me. See, we are going to take all parts of substring of length 3, and we are going to see how what is the maximum number of vowels, okay, present in any of the substrings, okay, of length 3. So first, let's consider this. A is a substring, sorry, A is a vowel, so we have count 1, okay. In this particular thing, count is 1. We have to return maximum possible count, okay. Now consider this, okay. So only I, okay, I is a vowel, so again 1. Similarly, this. Here, 2 I's are there, so okay. Here, 2, sorry, here, 2 I's are present, okay. That's why 2, okay. Now consider this. Here, 3 I's are present, okay, all are vowels, so 3. Now consider this. Two I's are present, D is not a vowel, so 2. Okay. So this E and I both are present, so 2. Okay. And finally D and F. In clearly see only E is a vowel. Okay. So 1. So we see that in this case, all of them are sorry, in this yeah, all of them are vowels. Okay. So the maximum possible answer is 3. So one thing you would have realized by now that the maximum possible answer is going to be K, and the answer is always going to be between 0 to K. Okay, that is one thing which is very clear. Okay, now consider this thing A, E, I, O, U, and we have to return K. Okay, so one thing you can see is see A and E. Okay, A and E. So see one more. See, this is kind of optimization. See if the first thing, see maximum possible answer is K. Once you okay, I will show that in code. But let us see the example now. So A, okay, two vowels are present. So first count is 2. Okay, we'll see if it is maximum or not. Again, these two are vowels. Okay, count is 2. Again, sorry, I and O again count is 2. O, U and U again count is 2. So in every possible substring, okay, 2 vowels are present. So the maximum is also 2. Okay, now consider lead code. Okay, you can clearly see in these okay, because case 3. So in these substrings we have 2 vowels. So answer is 2. Let us now come to the code. Okay. See, one thing, see, if you see the time complexity, it's not a small one, okay? So one thing is clear, we can either go for O of an approach or a n square, sorry, O of n log n approach. N square approach will not be possible, okay? So let us see what we can do. Before proceeding, one thing I would like to make it very clear, see what is the difference happening. Let's say example 1, okay? The first window is ABC, okay? The second window is BCI. Now if you consider this very keenly, what is the difference happening? See, we are removing the first character, okay, and we are inserting another character. This is how the window is moving, right? Please try to understand very cleanly. We are removing A and we are inserting I, okay. So suppose I know the number of counts. So I know the count of vowels here in this, okay. So how to get the number of so the count of vowels in this? What we can do is see the letter which I am removing, A is removed, I is inserted. Okay. So what I am doing is I will check if the letter being removed is a vowel. If it is a vowel, I will subtract 1 from my count. Okay. Suppose count is the number of vowels present in this string. Okay. This substring. If the letter which is being removed is that is the leftmost letter of this particular window, if it is like a vowel, I will do a -1 because this letter is getting removed. At the same time, the letter being added, if it is a vowel, I will do a +1 in my count. Okay, that is the basic idea here. Yeah. So what we'll do is keep a window of size k and maintain number of vowels in it. Okay, that is what we see. In the first case, you have to manually count. Okay, in the first case, you have to manually count how many vowels are present. But in the other cases, in every case after that, we'll just see if the vowel being added is a vowel. We'll do a plus one in that, and we will just see the vowel which is being removed. Is if it is a vowel, we'll do a minus one. Okay, that is the basic idea. Keep a window of size k and maintain the number of vowels in it. Keep moving the window and update number of vowels while moving. See, the brute force approach will be a O of n square approach. What we'll do, see, every time we'll see this is a window we'll take, we'll count number of vowels in, sorry, see, this is number, this is the window we'll take, we'll count number of vowels in that. Then the next window again we'll take, we'll again count the number of vowels in that. This is going to be n square approach, okay? So because of the time complexity, this is not possible. So we have to utilize the count which we made previously and we have to use it, okay? That is the optimization which we can do. So what I am doing is, see, count is, see, a file answer is a final answer. Okay, it is a maximum possible count. Okay, count is going to be the count of vowels in the current substring. Okay, what we'll do is see, which is my first substring, which is, see, recalling the number of vowels in the first k characters. Okay, 0 to k minus 1. This is going to be my first substring. Okay, see, substring is going to be of length k. So if you consider the index as what it will be, 0 to k minus 1. So this is my first substring. I will manually count number of vowels in it. Okay, I have taken vowels in a set. Okay, Python set. So I am just going to iterate from 0 to k minus 1 in my string, and I will check for each one of them if it is a vowel. Okay, what I will do a count plus 1. Okay, I will transfer the count to my answer as well. Okay, so this is for the first k vowels, sorry, first k characters. Okay, after that I will use the sliding window approach. Okay, see, this was for 0 to k minus 1. Okay, now this approach which we are going to see now is going to be for k to n minus 1. Okay, this approach which we are seeing is going to be for k to n minus 1. Okay, we are going to all the rest of the characters. See, this is my window, right? This is my window. For still here, I know how many counts of vowels are present. Okay, now I'm going to move my window by one. Okay, I'm going to include a new character. Okay, so what I will do, so this k is going to be my new character. See, because we did till k minus 1, right? So this k is going to be the new character for me. That means I, see, what is k? K, see, I is going to be initial k, right? So I is going to be the new character being inserted. Okay, so we'll just take if s of I is a vowel, we'll do a count plus 1. Count, what is count? Count is the number of vowels present in the first k characters. Okay, so this is we are going to utilize here. Now the character being removed is going to be s of I minus k. S of I minus k is the character which is going to be removed from my, like, see, it's a moving window, right? It's a sliding window. See, this was my window, right? I will move, see, ABC is my window. See, ABC is my window here, right? Now I will move this window to the right. If we move this window to the right, what will happen? A will be removed and I will be inserted. It will become BCI. Okay. So this is what we're checking. We are see the I is the one which is being added, A is the one which is being removed. Okay. This is how we are checking if I is a vowel, and this is how we are checking if A is a vowel. If A is a vowel, we have to subtract it from the count. If I is a vowel, we have to add it to the count. Okay. Finally, we'll have the count for the current window. Okay, so we'll just see if it's, we'll see, we are, see, finally we have written the maximum, right? So we are just going to consider it for the maximum, and if it is maximum, it will update the answer. Okay, I will print and show you as well how this is being done. Let us quickly see. So yeah, this is going to be the string. Let us see how the window works. Okay, see, for ABC, so k is 3, right? So we have to consider only substring of length 3. ABC, we can say A is a vowel, so length 1. Okay, count is 1. Okay, now coming to the next substring, which is VCI. You can clearly see I is a 1. Okay, I is a vowel, so its count is 2. Similarly, CIA, 2 as a parent, so it is 2. This is going to be 1, which is going to be the answer. Okay, and for the rest also, so D and E students, so its count is 1. So that is how it is being done. We are using sliding window approach, and its time complexity is going to be over. Okay, because see, this is for the first k, and this for the, sorry, this from 0 to k minus 1, and this is for k to and minus 1. So totally we are, see, process, in terms of processing, we are using only O of n of the compiler power. Okay, O of n of the processor power. And in terms of space complexity, we are not storing it in any, see, we are just using variables here. Okay, we're not using an array, so it's O of 1. So yeah, friends, this was a medium level question, but it was on the easier side. If you have, see, one optimization which I can tell you is, see, one thing is very clear, the answer is always going to be between 0 to k. Okay, and we always have to take the maximum. Okay, so while doing this, if you get the answer as k, okay, if you can add a if condition here, Okay, after this you can add if condition. Okay, in this part, if answer is equal to k, then you can break the loop here. Okay, this is how it is going to be. If answer is equal to k, okay, you can just break the loop here because we don't need to do anything further, because the answer is the maximum answer is going to be k only. Okay, so if I run this again, it will kill the test cases. So it's these are like small optimizations we can think of, right? I will give this code, we can go through it. And one thing you have to notice that whenever you're submitting the code, always comment the print statements. Okay, otherwise it will reduce your performance of your code. Okay, so yeah, friends, I will give you this code, and yeah, that was all for today. If you have any further optimizations possible, if you can think of it, please do comment below, and we can discuss further. Yeah, thanks a lot.